Good evening. My name is I'm going to be showing us how we can be able to create a machine learning algorithm. That is how we can be able to create linear regression algorithm from scratch. So first and foremost, I will just give a brief introduction to what machine learning is all about. So machine learning is all about feeding a model or a computer or a machine, feeding it data and allowing that machine to analyze and read that data so that it can be able to predict future outcomes from the data. So you are giving machine or computer data, the computer and machine is going to analyze that data and learn from it, and then it's going to give you a feedback or predict future outcomes based on the data you have supplied it with. So Python has a lot of modules or a lot of files that allow you to carry out machine learning algorithms efficiently. But at the same time, machine learning algorithms are built by mathematical or are built using mathematical formulas or equations. So I'm going to show you how you can be able to write a simple linear regression model or algorithm from scratch using Python and mathematics alone. So I have a Python script that allows us to be able to carry this out. So I will be uploading that very soon so that you can see what goes on. But what we are trying to do, or what we are going to do, we are going to have two data sets. So the first data set is going to have the values of, that is, we're going to have value on some people's age. So it's going to have data on the age of a group of people, which is going to be our x, that is our independent variable. So an independent variable is a variable that does not depend on any other value or coefficient in an equation, while a dependent variable is a variable that depends on the solution or the outcome of the independent variable. So we're going to have two data sets, our x and our y, our x being our independent variable and our y being our x being our independent variable and our y being our dependent variable. So we're going to supply both parameters data, and our algorithm is going to predict based on that data future values of y, which is our dependent variable. So I'll be showing you how you can do that, how you can craft that out from scratch using Python and mathematics. So the first thing we're going to do, we are only going to make use of one Python module, which is NumPy. Now the reason why we're making use of this module is because this module is going to allow us to find the inverse of a matrix. So the module is going to allow us to find the inverse of a matrix, and if we are to try to find the inverse from scratch, it's going to take a lot of our time. So to be better, we just use the NumPy module to find the inverse. But every other thing, such as us getting the coefficients that our equation depends upon, is going to be gotten from scratch. So now the first thing you want to do is to import NumPy. So you say import NumPy, then we'll create a class, we'll call it regress. So you can give your class any name. I will be doing later videos explaining in Python. So Python is an object-oriented programming language. So I have data on age. I have some data on age, so I'll just reach out for it. So I have a data on age. So I will be supplying that. Just a minute, I'll be with you. Alright, so we have the ages of some people. So we have 24, we have 23, we have 27, we have 29, we have 22, we have 21, 27, we have 30. So these are our values of our x-axis, which is our age. Then we have height. The height is going to be 172.4. We'll have 171.48. We have 177.52. We have 179.34. We have 170.53. We have 169.94. We have 176.94. Sorry, 0.98 rather. 98. We have 180.0. Right, so these are our values. So it is also advisable for us to create a copy of our x and y axis, and I would explain to you why that is. So the reason why we're making a copy is because we're going to make use of a for loop. So a for loop is a process in Python or in any programming language that allows us to repeat an iteration in a program until we create a conditional statement that allows us to break out from that while loop. So subsequently, I will be explaining more on that when I treat my other courses on Python. But for now, this is just us trying to create a simple linear regression algorithm from scratch using Python. So we're going to create another function called pred, and this function will allow us to start. So the first thing we're going to do, we're going to try to find the sum, that is the length of our entire data set. So the length of our entire data set, just a minute, I'll be with you. Alright, so the length of our entire data set, I'm going to call it n. So n is equal to the length of self.age. So this has automatically given us the length of our x-axis. So now the next thing we're going to find is to find the sum, that is adding everything inside our age together, adding all the values together to get the length, which is the summation. So I will be sending the picture of how the equation looks like. So basically how the equation looks like is that we have a matrix, we have a 2x2 matrix that has the length of our data set, has the summation of the x values, has the summation squared of the x values as well, and we're trying to multiply that matrix by our coefficients b0 and b1. So our coefficients are going to be the determinants that are going to allow us to predict future values of the height. So subsequently I will be doing other videos to explain what that means. Well, what we're trying to do, we're trying to find the sum of the age, and the next thing we're going to find is the summation of y. So that's going to be self.height. Alright, so we have that already. So now the next thing we're going to find is summation x squared, which is going to be equal to sum. So now we're going to use least comprehension to be able to square each value of our x, which is going to be inside our age, and at the same time, as we square each value, we are going to store the result inside a list. So raised to the power of 2 for x in self.age. So what this simply means, or what this simply does, this is just doing the same work as our self.age. It's just creating a list, but this time around it is using a for loop to loop through this list, take the first value, raise it to the power of 2, add it inside a new list, take the next value, raise it to the power of 2, add it into that same list as well, and it just repeats the process over and over again till it gets to the last value inside that list. So I hope that was clear. So the next thing we're going to do, we're going to create an empty list first of all for our x and y, and then we're going to try to multiply them together. So we're going to loop through the copy of x and through the copy of y, which is our self.h copy and our self.height copy. So we're going to take the value. So I'll be explaining that anyway. So I would create a while loop. I'll say while self dot x copy, while self dot h copy, rather while self dot h copy. So you loop through that and you create a for loop. You say for y in self dot height copy. So we are looping through our x and y. And the next thing, you create a variable for your x. You say self dot h copy dot pop. So we're going to be removing value from our x, and as we remove each value, we're going to add it into our list. So this is what I'm trying to do. So now the while loop allows us to be able to loop through each value inside our h copy. So it's going to loop through. So the copy of our age is just the same thing we have here, 24, 23 down to 30. We're looping through each value one after the other, and we're removing them. So as we loop through the list, we start the while loop through that list, take the value, take 24 out, and multiply it by this y. But as we're taking 24, we're removing it from that list. That's what the pop function does in Python. So all these are all Python functions that we are trying to combine together with our knowledge of maths. You say x multiplied by y, then after you are done with that, you are going to add them to the list. So we use the append function. So the append function is an inbuilt function in Python that allows us to add elements to a list, which is a data structure. So after that, we're going to sum our x and y together, sum all the values inside the xy list. So mind you, like I said, we're taking values from our self.h copy. That is, we're going to remove the first value at the 0 index, which is the first element, multiplied by the first element inside our y. And as we multiply them together, we're going to store them inside a variable called res, and we're going to use the append function to put the value of that variable inside the xy list, and we're going to repeat the whole process again till we get to the last element in both lists. We're going to repeat the process all over again till we get to the last element in both lists. Then we're going to have a new list of x and y that comprises of the multiplication of x and y together as elements each inside that list. So you see summation of x and y. So you're going to add them together. So we have our summation xy. So now we can now build our algorithm to carry out our prediction. So we have already imported NumPy already. So the next step we're going to take, we're going to create a matrix. I'll call it matrix 1 is equal to NumPy dot linear algebra. So now there's a function in Python, in the NumPy module called linalg. So this is a linear algebra function, and of course we know that we carry out that is for the mathematicians. We know that when we deal with matrices, we are looking at linear algebra, which is a very, very important topic to master if you want to look at machine learning. Okay, but before this matrix, we're not going to find an inverse yet. We're going to create an array first of all, so that we can store each of our values. So I'm going to create a two-dimensional array with two one-dimensional arrays, and inside this array, I'm going to store my n, and I'm going to store my summation x. And after that, I'll create another one-dimensional array, store my summation x and my summation x squared. Okay, I don't know why this is doing that. Summation x squared. Alright, so I've stored my values inside the array. Alright, so now the next thing I'm going to create is my second matrix, matrix 2, which is going to carry out the whole process again, create an array. But this time around, I'm going to have a zero-dimensional array, or rather it's a one-dimensional array because it just has one array. Arrays are rows of matrices. You have y, the summation y, and then we have a summation xy, summation xy. Alright, so I've created our matrix. Now we have to find the inverse of this matrix, of our matrix 1, not our matrix 2. So you say inverse matrix 1. So the inverse of matrix 1 is going to be equal, it's going to be equal to numpy dot linear algebra dot inverse. So the inverse function allows us to find the inverse of a matrix. So you say matrix 1. Matrix 1. So I found the inverse of our matrix 1. Alright. So after we found the inverse of this matrix 1, we want to convert it to a list. So I'll say inverse matrix list. You convert it to a list. So you say inverse matrix 1 dot to list. So these are functions that we use in Python. I am not teaching Python as of now. I'm teaching machine learning. Like I said, subsequently I will be releasing videos on Python and how you can start your machine learning career with just knowing Python and mathematics. It's not really that hard. Alright, so after this, I'm going to find, now a list has elements, but now inside this list, this is going to be a list that has two other lists inside it. So it's going to basically be a list of lists. That's what it's going to be. So now I will just say first. So first is going to be equal to inverse matrix lists at the 0 index. So this allows me to print out the element at the 0 index of that list of my inverse matrix. I'll say inverse matrix list. I just want to print it out so that you can see our value. So in my alright, I'm coming. Just a moment. Okay, so in my terminal, I have I can be able to execute my Python code here. And be able to execute my Python code. So I'm going to call my class, which is called regress, and since my function is inside my class, I will call the function inside there. So after that, I'm going to execute the program. So you see we have our list of lists. We have a list that has two one-dimensional, or rather we have a list that has two lists inside it. So we'll continue from there. Alright, so continue. So now back to our program. So I've created the first list. I've filtered out the first list inside that major list. So the next thing I want to do is filter out the second list inside that list. So I'll get the value at 1 index, which is my second. So I'm done. So now I would say while first. So now I want to be able to take my list, the first list, and multiply it by the values in my my second matrix. So I have a matrix called matrix 2. So at the same time, I also want to convert that to a list. So I'll just say matrix 2 list is equal to matrix 2 dot to list. So I've converted this to a list as well. So after that, I'll create a for loop. I'll say for y in matrix 2 lists. So this is going to be my second list, and after that I'll create a result. So result is equal to I'll say x. First of all, x is equal to first first dot pop in the element, the 0 index. So as I remove that element, I'm going to multiply it by my y, say x multiplied by y, and after that you're going to append that. So now we want to be able to create b0 and b1. So I'll just say var1, I'll just call them var1 and var2 for now. Then later on I would call them b0 and b1. Like I said, this is just a video that shows you how you can be able to create linear regression from scratch using Python and math. Alright, so I'll copy this function. It's going to be the same thing as another function that I will create. So I'll change this one to second. Then you say x second or pop. So it's the exact same thing I just did. So after that, we're going to create our algorithm, our b0. So I'll say b0 is equal to the summation of our 1. And we'll say b1 is equal to summation of var 2. So we have our b0 and b1. So I'll say y is equal to b0. So this is our linear regression formula multiplied by x. But we don't have x yet. And I'm trying to return back a value, which is y. Alright, so now go back to our function and we're going to create a value for our x. So you create a value for the x, create a value, and you save your results. Then here, so now we said our our x is going to be the age of a person's. So now the value I supplied for my x was 24, and the data I supplied, that is, I said the person's height at that age, someone who was 24, had a height of 172.4 centimeters. Now this was the data set I supplied to the algorithm. But now the algorithm is going to try to guess, it's going to try to predict what it thinks the person's height would be if the person is 24 years old. So let's try that. So I'm trying to predict this algorithm. So the person, okay, now the algorithm predicted 144.9. But let's check our initial data set and see where we fell short. So it's supposed to give us something close to that value. It's supposed to give us something close to that value. So let me check another value. 25. Okay. 6. Okay, so let's check our function. There was an error somewhere. Apparently that's why it keeps giving us the same results. Just check it. It was matrix 1. Okay. Okay, x squared. So the age